Hello again. We're going to switch gears with this unit, this new unit, and instead of talking about sequences that go off infinitely, we're going to talk about infinite series and the difference between those and infinite sequences. All right, well, with sequences, we've been talking about UN and whether or not those converge. Now we're going to talk about a series, which is actually the sum of a sequence. So we're actually adding up all the terms of that sequence that goes off to infinity. But before we talk about going off to infinity, we need to talk about what partial sums are. So we have our sequence. The first term is U1, the second term is U2, and so on. The partial sum S1 is just going to be the sum of the first one terms, which is basically the first term. S2 is going to be the sum of the first two terms, so U1 plus U2. S3 will be the sum of the first three terms. S4 will be the sum of the first four terms, and so on. So that's what partial sums are. So how do we calculate them? Well, in order to come up with a general rule, I kind of figure out what the first few partial sums are, and I see if I can find a pattern. All right, so for example, if the nth term is 2 to the negative n, starting at n equals 1 and going up, then 2 to the negative 1 would be a half, 2 to the negative 2 would be a fourth, 2 to the negative 3 would be 1/8, and 2 to the negative 4 would be 1/16. So that's the sequence. Now I need to find the partial sums. Well, the sum of the first one term is just the first term, and that's a half. The sum of the first two terms is 1/2 plus 1/4, and that's 3/4. The sum of the first three terms would then be 7/8. The sum of the first four terms would be 15/16. So in general, I have that the nth partial sum would be 2 to the n minus 1 all over 2 to the n. All right, here's another example. Let's say I have each term is negative 3 to the negative 2k, and k starts at 1 and goes off to infinity. That means that the sequence is negative 1/9 plus negative 1 over 81 plus negative 1 over 729 plus negative 1 over 6561, and so on and so on. So the first term, which is also the first partial sum, is negative 1/9. The sum of the first two terms would be negative 10 over 81, then negative 91 over 729, and then negative 820 over 6561. This is a geometric series where a is negative 1/9 and the r is 1/9. That's for the sequence. So for the series, I just use my sum of a geometric series, and I plug in my a value of negative 1/9 and my r value of 1/9, and I simplify, and I get that the partial sum is 9 to the negative n minus 1 all over 8. All right, so if I am finding the sequence instead, so up until now I've given you the sequence and asked you for the partial sums. Now I'm doing the exact opposite. I'm giving you the partial sums and I'm asking you to find the sequence. Okay, so what I know is that the first term is equal to the sum of the first one terms. So that's an easy thing to find. The second term is just going to be the sum of the first two terms minus the sum of the first one term. The third term is going to be the sum of the first three minus the sum of the first two, and so on. All right, so in general, I have that the first term is equal to the sum of the first term, and then the kth term will be the kth partial sum minus the k minus 1 partial sum. All right, so let's say I have the formula for a partial sum is 3n squared minus 1. Well, the first term is just going to be me plugging 1 into that formula and getting a value of 2. So the first term is 2. Then I need to figure out what the kth term is in general. So I'm going to take the k sum and subtract the k minus 1 sum. Basically replacing n with k and n with k minus 1. And then kind of simplifying. Well, the 3k squareds cancel, the 1's cancel, and I'm left with 6k minus 3. So in this sequence, the first term is 2, and then every term after that is 6k minus 3. All right, another example, if the nth sum is the natural log of n, then the first term is the natural log of 1, which is 0. The kth term is going to be the kth sum minus the k minus 1 sum. So that's going to be the natural log of k minus the natural log of k minus 1. Now, if you remember your properties of logarithms, you know that when you're subtracting logarithms, you can divide the arguments. So we get that the kth term is the natural log of k over k minus 1. So that's that sequence. The first term is 0, and every term after that is the natural log of k over k minus 1. All right, so that is partial sums. And if you have any questions about that, please let me know, and I will see you tomorrow.